gravity and density.
Under extreme pressure because
creates
of extreme
heat,
gravity and intensity.
and that fuels
Creates
solar
heat.
fusion,
That
which
fuels solar
powers the
fusion.
star. So how does pressure create heat? Aerospace engineer Sigrid Close has a device to show just how easy it is.
So a lot of people think that the bigger a star is, the more likely it is to create fusion inside. It's actually not true. It's all about the pressure and the temperature. We need a high enough temperature to overcome something called the Coulomb barrier. Basically, particles don't like to get near each other. If you have like particles, they want to stay away from each other. The key is pressure and temperature. So you have enough of it, then you can overcome that Coulomb barrier and actually create fusion.
The pressure and temperature overcomes the
So how
Coulomb
can we
barrier.
create fire without a
fusion.
match? Actually, you can do it with pressure, and I'm going to show you how. What we have to my right is a plunger, and here is flash paper. The idea is that we're going to put this flash paper inside that plunger and create enough pressure to ignite this. You see what happens.
Pressure, plunger, creating a fire from these materials using pressure.
So I'm a
Flash
little
paper.
vertically challenged. I need to get a little bit more height so that I have a little bit more force to push down and actually ignite this flash paper. 1, 2, 3. Ta-da!
By rapidly compressing the air with the plunger, molecules are smashed together, creating friction and heat. The greater the pressure, the higher the temperature. And poof goes the flash paper.
There was a bit of a kickback. I'm actually a little sore here right now. So even though this demonstration isn't exactly what happens in stars, the concept is pretty similar. In stars, you need a high enough pressure to basically overcome this Coulomb barrier, which wants to keep the particles apart. Same concept here in that we needed a high enough pressure to ignite this flash paper. So again, it all comes back to not the size of the star, but about the temperature and the pressure contained within
Not the
the star.
size, but the temperature and intensity.
Pressure creates intense heat in the most powerful stars. But the hardest hitting force in the universe isn't a living, fire-breathing star. It may be a dead one. The size of the big dog and the heat of Rigel are about to be blown away by the violence of another monster in the universe.
Every tank veteran has